Our video topic is all about mathematics in our world.
So, what is mathematics? Mathematics is the science of structure, order, and relation that has involved elemental practices of counting, measuring, and describing the shape of the object. It is also a tool to quantify, organize, and control our world, predict phenomena, and make life easier from us. Where is mathematics? Many patterns and occurrences exist in nature, in the world, in our life. Mathematics help make sense of those patterns, occurrences. Next, the importance of mathematics. Math is good for the brain, promotes logical and analytical thinking. Math is also helpful with your finance. With the help of math, you can easily make your financial budget. You can calculate how much money you have and how you can spend your money. Almost every single human in the world use math for their finances. Time management. We know that time is the key to success for everyone. Therefore, we have to be more calculative for the time management. Math helps us to do better time management. The importance of math is reflected in the time management task. It has also helped us to make a wise decision on how you spend your time effectively. Every career uses math. There is no professions in the world that doesn't use math. Engineers also use math to perform their daily tasks, from blue-collar factory workers to the managerial level. White-collar professionals, everyone use math in their work. Math also helps you to understand the world better. Did you know that everything in nature is based on math? Even math offers us the golden ratio formula, which allow you to get the beauty of anything. If you want to judge the beauty of something, then you can perform the golden ratio on that thing to declare a beautiful or not. Every single part of nature is based on math. You can also do math calculation to understand natural creation. Honeybee. It is the master of geometry. It is used hexagonal to make the honeycombs. A great sequence of numbers. The Fibonacci sequence is found everywhere in nature. Shells, pine cones, tree, leaves, and flowers. Patterns and numbers in the nature and the world. Patterns in the nature are visible regularities of form found in natural world and can also seen in the universe. Nature patterns are not just to be admired. They are vital clue to the rules that govern natural process. Patterns define as regular, repeated, recurring forms or design. Identify relationship, find logical connection to form generalizations, and prediction. Types of patterns. 1. Symmetry. A sense of harmonious and beautiful proportion of balance, or an object invariant to any various transformations, reflection, rotation, or scaling. The picture of butterfly showing below, it is the example of Bilateral symmetry. A symmetry is which the left or the right sides of the organism can be divided into approximately mirror image of each other along the middle. And the picture of the right side, it is the example of radical symmetry, a symmetry around a fixed point known as the center and can be classified as either cyclic or dihedral. Snowflakes. Snowflakes has a special property. No matter how we zoom in, we'll see the same patterns over and over, that never-ending patterns. This is called a fractals. Spiral. It is a curved pattern that focuses on the center point and a series of circular shapes that revolve around it. Example, the snail, typhoons, and the pine cones. Did you know that there is a math in snail? When you cut the shell of the snail in half, that is what we call the golden spiral, which is a series of squares which a length of side of 1, 1, 2, 3, 5, and so on. That's we call the Fibonacci sequence. The Fibonacci sequence. Fibonacci, also known as Leonardo Bonacci, Leonardo of Pisa, or Leonardo Bigolo Pisano. He was an Italian mathematician from Republic of Pisa, the most talented Western mathematician of the Middle Age. Origin of Fibonacci sequence. Fibonacci sequence was discovered after an investigation on the reproduction of rabbits. It takes a month for a young pair of rabbits become an adult, and it takes another month before an adult rabbit bears another pair of young rabbits. Therefore, the month of 0 there exists of one young pair of rabbits. After 1 month, the pair of young rabbits become an adult. Still, we have one pair of rabbits. After another month, the pair of adult rabbits, of course, they are still adults, but the adult pair of rabbits bear a young rabbit. So, it's now leads to 2 pairs of rabbits. After another month, the pair of adult rabbits bear another pair of rabbits. Each, the pair of young rabbits become an adult, which leads to 3 pairs of rabbits. So, now those numbers of pairs of rabbits are what we call the Fibonacci sequence, where we have 1, 1, 2, and 3, and so on. Fibonacci sequence is an integer in the infinite sequence of 1, 1, 2, 3, 5, 8, 13, and so on, which the first 2 terms are 1 and 1, and each succeeding terms is the sum of the 2 immediately preceding. A simple rule: add the last 2 to get the next. For example, if we add 1 and 1, we have 2. To get the next number, all we have to do is to get the last 2 numbers and then add it together. The next number, so 1 plus 2, we have 3. Then to get the next number, all we have to do is to add them, the last 2 numbers. In this case, 2 and 3, and Add them together, we have 5. And the sequence of numbers continues. F sub n is equal to fn minus 1 plus fn minus 2. For example, if you want to get the ith term of Fibonacci sequence, all you have to do is to get f sub 8 minus 1 plus f sub 8 minus 2, which is f sub 7 plus f sub 6, which give us 13 and 8. So if we add 13 plus 8 is equal to 21. Therefore, f sub 8 is equal to 21. The golden ratio. The golden ratio is often denoted by the Greek letter P. This is approximately equal to 1.618 or 1.618. The golden ratio can be expressed as ratio between two numbers. Mathematics for organization. For us to make a sense of all available information, we need mathematical tools to help us make a sound analysis and better decision. For example, scientists can plot breed migration routes to help conserve endangered animals populations. How does organizing help students? It supports them in more easily seeing pattern in learning mathematical concept. It's guide their thinking about what they do and don't know about the problem. It's give them ideas of way to approach solving a problem, and also help them to maintain chunk information in memory to use in problem solving. Mathematics helps predicts the behavior of nature and phenomena in the world. Mathematics for prediction. It is something said that history repeats itself. As much as we can use mathematical model using existing data to generate analysis and interpretation, we can also use them to make a prediction. By applying the concept of probability, expert can calculate the chance of an event occurring. For example, the weather. Based on historical patterns, meteorologists can make forecasts to help us prepare for our day-to-day activities. They can also warn us of weather disturbance that can affect our activities for a week or a month. Mathematics helps control nature and occurrence in the world of our own end. Mathematics for control. There have been instances when a natural phenomena has been speculated to exist because mathematics say so, but no hard evidence has been found to support its existence. Such phenomena were proven to exist only when advancement in technology have been allowed us to expand our horizon. In 1916, Albert Einstein hypothesized the existence of gravitational wave based on his theory of general relativity. In 1916, Albert Einstein hypothesized the existence of gravitational wave based on his theory of general relativity. This is when ripples are formed in the fabric of space, time due to large violent cosmic events, very much like when people is thrown on stagnant pond. The laser interferometer gravitational wave observatory or LIGO announced that it's found evidence of this phenomena. Ripples means a small wave. Through the use of mathematics, man is also able to exert control over himself and the effect of nature. Mathematics has numerous applications in the world, making it indispensable. Mathematics is indispensable. In Tagalog, ang matematika ay kailangan na kailangan. Whether you are on your way to become a doctor, an engineer, an accountant, a public servant, or a chef, a knowledge of mathematics will be helpful. At the most basic level, logical reasoning and critical thinking are crucial skills that are needed in any endeavor. A source of study of mathematics should be embraced as it is the way for more educated decision and any bring us closer to understand the natural world.
Good day, everyone. I am Jeremy Laksa Marmol, a former student at Sorsogon State University, taking up Bachelor of Engineering Technology, major in Electrical Technology. In this video lesson is all about mathematical language and symbols. Language of mathematics. The system used by mathematicians to communicate mathematical ideas among themselves, and is distinct from natural language in that it aims to communicate abstract logical ideas with precision and unambiguity. Characteristics of mathematical language. Precise. Mathematical language is able to make very fine distinctions or definitions among a set of mathematical symbols, unlike ordinary speech, which is full of ambiguities, innuendos, hidden agendas, and unspoken cultural assumptions. Next is concise. Concise is long expositions or sentences can be expressed briefly using the language of mathematics. And also symbolic. Mathematical language can describe a subset of of the real world using only the symbols. Next is powerful. Mathematical language is able to express complex thoughts with relative ease. Devoid of emotional content. Devoid of emotional content, there is absence of emotion from formal mathematical discourse. Next is non-temporal. Non-temporal is there's no past, present, or future in the mathematical. It is not affected by time. Another characteristic of mathematical language and symbols. Common mathematical symbols. These are the symbols that we usually use solving mathematical problems like additional, subtractions, divisions, and also multiplications. In this slideshow, represent the different type of mathematical symbols and sign like multiplication, addition, divided by, minus, and etc. Next is mathematical convention. A mathematical convention is a fact, name, notation, or usage which is generally agreed upon by mathematicians. For instance, the fact that once evaluate before additions in the expression 2 plus 3 times 4 is nearly conventional. There is nothing inherently significant about the order of operations. Next is 4 basic concepts. Sets. A set is the representation of a collection of objects, distinct objects with one or more common properties. There are ways to represent a set. First is statement form, roster form, set builder form. Next is relation. A relation is any sets of order pair numbers, the couple pairing, and the pairing of the student name and courses taking are examples of relation. Example of relation representation is relation in table, relation in graph, and also relation in mapping diagram. Next is binary operation. Binary operation on a set is a calculation involving the two elements of the sets to produce another element of the set. Addition, subtraction, multiplication, and division. Exponential is sum of the binary operation. Properties of binary operation: commutative, associative. Another characteristic of mathematical language and symbol. Elementary logic, connectives, quantifiers, negation, and variables. First, logical connected.
Probabilities and normal distribution.
gathering and organizing data, learning objectives, statistics, populations and samples, sampling methods. Example 1. Choosing a sample. Descriptive versus inferential. Example 2. Constructing a frequency distribution. Frequency distributions. Stem and leaf plots. Measures of central tendency. Introduction. Central tendency or average. Definition. Functions of average. Characteristics of a good average. Arithmetic mean. Methods to solve individual series. Methods to solve continuous series. Disadvantages of mean. Geometric mean. Geometric mean using logarithmic calculation. Calculation of individual series. Calculation of discrete series and continuous series. Average rate of growth of population. Harmonic mean. Calculation of harmonic mean, discrete and continuous series. Median. Calculation of median, discrete series. Calculation of median, continuous series. Merits of median. Disadvantages of median. Quartiles, deciles, and percentiles. Mode. Advantages of mode. Disadvantages of mode. Conclusion. Measures of dispersion.